All right, so the first order of business here is to return the midterm exam to the in-person student first, and then we will continue with our lecture. All right, so last time we talked about the context-free grammar. All right, so now we're going to talk about how to parse the grammar. Okay. So let's recap. So in the lexical analyzer, we convert a stream of character to a stream of token. Okay. So those unwanted information, for example, comments, tab, space, new line, those things being removed. So now passing to the parser is a stream of tokens. So which class they belong to. For example, the operator, the integer, or the equal size, whatever they may be. So those are the token class. Okay. So the input of the parser is a stream of tokens. It's a stream of tokens. All right. So now let's consider this grammar. Okay. Here. So the grammar here. So we're starting from E. Okay. E can go to T or T plus E. And T can go to ID or ID times T or left parenthesis E, right parenthesis. Okay. So this is our grammar. And our input is left parenthesis ID and right parenthesis. Okay. So this is our grammar and this is our input. We want to make sure if this input is valid. All right, following the correct grammar. Okay. So it's a tree. So it's starting from the start symbol. So that's the start symbol is our root. So which is E. Okay. So in E, we have two choices, T or T plus E, right? T or T plus E, right? So we don't know which one. So let's say we pick the first one. So T, okay? So then go to T, the production T. T goes to ID or ID times T or left parenthesis E or right parenthesis E, okay? I don't know which one to choose. So let's say we choose the first one, okay? Then we expand, T become ID, okay? Then we're going to do a match. So ID is a terminal. So we're going to match with our input. The first character of our input is a left parenthesis. So it does not match. So it is a mismatch. Right? So this row is a mismatch. Okay? So what we're going to do? We're going to backtrack. We're going to backtrack and try the next one. Try the next one. All right. So now T is being expanded by ID times T. Okay. So ID is a terminal. And we're going to match with our first character from our input, which is left parenthesis. Okay. They do not match. All right. So it is a mismatch. Okay. Make sense? So what we're going to do, we're going to backtrack and try the next one. Okay. So next one, that will be left parenthesis E and right parenthesis. The left parenthesis, which is a terminal. Okay, then we're going to do a match. So this time it matched the first character of our input. So this one's a match. Okay. The next one is E. E, then we come back here, right? We come back to E. Okay. So then E, we have two choices, either T or T plus E. We don't know which one, right? Then we choose T. All right, we choose T. Okay, we choose T. Then E is being replaced by T. Okay, so now is T. So we have ID times T, and left parenthesis of E and right parenthesis. So we don't know which one. So we got to choose the first one first. So this one's ID. Okay. So we got replaced by ID. And ID is a terminal. So we'll match with our second character. So which is ID, which is a match. Okay. Then the last one, move to the last one, which is also a terminal. And we'll match with the next character. Okay. So it's also a right parenthesis. So this time it match. Okay. So, and it has no more thing after my grammar. Okay. And the input is ended. So this means the input is valid. Okay. So far so good. Is it clear? All right. So this is called recursive descent processing. All right, this algorithm called recursive descent processing. So as you've seen, okay, it requires backtracking. It doesn't know which one it is, right? I don't know. I just pick the first one, right? First one doesn't work. I have to backtrack to the original, to the production, and choose the second one. The second doesn't work. I will backtrack to choose the third one, and so on. So it's very inefficient. Okay, it's very inefficient. So we would like the algorithm to work without backtracking. All right, without backtracking. Okay, so we'll see how. Okay, we'll see how. So before we talk about that, we'll talk about the grammar first. So next we're going to talk about left recursion enumerations. Okay. So the following grammar here, this is a left recursion. So you see S is a production, go to S and A. Okay, so it's a recursion. So this is a recursion calling itself, and the recursion is on the left side. Okay, so this is called left recursion. Okay, and the recursive descent parsing algorithm does not like this type of grammar. So you cannot write this type of grammar. Okay, so period. Yeah. So what are we gonna do? We need to rewrite the grammar. All right. So last time we all learned how to rewrite some of the grammar. So now we're gonna learn how to write in specific the left recursion. So the thing we want to do is to make the left recursion production to a right recursion production. Right recursion is okay. Left recursion is not okay. Okay, so you need to know what is the left recursion, what's the right recursion. All right, left recursion means your recursive call is on the left. On the left, it's not okay. On the right, it's okay. Okay. So take a look at this example. S, right? S goes to S alpha or go to beta. So this is a left recursions, right? Because the recursive call is on the left. But before we're trying to rewrite it, we need to understand what it generates first. What does this production generate? Okay, so you can choose beta, right? And it will be 1 beta. That's it. Or you can choose S alpha, okay, and recursive call, right? Then come back and choose S. And your S could also choose S alpha again. And it become 2 alpha. You choose that again, it becomes 3 alpha. Right? Eventually, your S has to be choose beta. Right? Then your S will be gone. It will be replaced by beta. Okay? So this grammar is a beta followed by any number of alpha. Okay? So convince yourself this is what it generates first. Does that make sense? You have to know what you're just rewriting the grammar. You're not changing the grammar. Right? If you change the grammar, then it's going to generate different string. That's wrong. Right? You have to rewrite the grammar so that it will generate the same output. Okay. So far so good. So everyone understand what this grammar does. Right? So what is this grammar, right? Generate. This grammar, like I said, it could choose betas, right? It's only two possibilities. I can choose S alpha or I can choose beta. All right. I choose beta. That's a 1 beta. Okay. Or I can choose S alphas, right? S alpha. So S alpha. So next time, if this S, I choose beta, so this will become beta alpha, right? Beta alpha. Make sense? Or if I don't choose beta, I choose S alpha again. That's become S alpha, right? So next time, so I can choose beta. So the beta alpha, right? Or I can choose S alpha, then followed by 2 alpha here. Right? So if I design this as, I choose a beta alpha, right? So this is the language, beta followed by any number of alpha, right? Alpha could be 0, right? Or median of alpha. Is that clear? Good. All right, so now we know what this grammar generate, then we are trying to rewrite it, right? So that it will generate the same output. Okay, so the goal is to eliminate the left recursion. Okay, how do we do that? Okay, we can rewrite it in the following. S goes to beta S prime. Okay, so it could be 1 beta, right? We show it, we could be 1 beta. That's okay. We add a epsilon here. S prime can go to epsilon. Okay. Or what is language generate? Beta followed by any number of alpha, right? Can follow alpha. Recursive call S prime call again. It can be epsilon or can be alpha. All right, so that means it's generating this beta followed by any number of alpha. Same language. All right, same language. All right. So now look at the recursive call. Where are the recursive call? Recursive call is here, S prime. It's on the right. It's no longer on the left. Okay, remember, right? Recursive descent algorithm does not like the recursive call on the left. Okay, so we rewrite this grammar. Now the recursive call is on the right. Are we clear? Everyone convinced? Right? It is the same grammar, and that it is not a left recursion. Good. All right. So here is a general rule. So there's a general form. You could have S alpha 1, S alpha 2, S alpha 3 to S alpha n, beta 1, beta 2, beta m. Okay. And that's how you convert the left recursion to right recursions. So you're going to write beta 1 S prime, beta 2 S prime to beta m S prime. Your S prime is going to be alpha 1 S prime, alpha 2 or alpha 2 S prime, or alpha n S prime or epsilon. So this is a general form. Okay. Everyone understand this? Any question on that? You probably don't really know, right? Until you actually trying to do it yourself. Okay. We're good on here. So here I want to show you one exception. It's okay for left recursions. So if the production rule, if the beta, one of your beta is the epsilon, then that's okay. Okay. If your beta is the epsilon, all right, and the left recursion is okay. All right, otherwise you need to rewrite it. So this is the requirement for the recursive descent algorithm. All right. Basically, it does not like left recursion. Okay. Everyone remember that? Okay. All right. So I have an exercise for you. Okay. So here, S goes to A alpha or delta, and A go to S beta. So you can substitute S goes to A is being replaced by S, and beta followed by alpha or deltas, right? So you can see S is the recursive call, okay? And it is on the left, all right? We don't like this type of grammar. So your task is to rewrite this grammar, right, to become a right recursion. Yes. It's possible. It's possible for a rule. It's a rule. Right? Look at the last example of the rule. What's the grammar here? What's the grammar? Here. It's still left because the S is still here. This is the S, right? It's on the left. This one. Still. What do S one is still? That's M. What else can it? 75. That's S1 divide. Delta 1. There's no delta 1. There's only one delta. See? Where's the star? That's the star. Yeah, what's the production star? Okay. Yeah, that's fine. Why is on that? That production. What could be more? The channel phone is showing you it could be more. Could be more, but here's only one. But could be more. This example, we have one delta. Delta. Alpha, beta, right? Or the all other things. We want more. See, where's the grammar? Where's your organ? So what? Yes. So that's what I wrote, right? That's over there. We want the recursion. That's on the right. So what is A? Where is A? A is beta. A is beta. Now let's see. Where's your ground? Let's see. Where is it written? Here. A. Go to beta. It's not the same ground. Not the same ground. You see this, right? You got to change. A. This is beta. That's fine. Fine, right? That's fine. Delta. Okay. So what are you generating? Beta. Beta alpha. Beta alpha. So let's say we're going to replace. Replace what is this, right? So beta alpha, that's fine. So you start with beta. And here, look at it, right? You must have delta. In your grammar, you do not need to have delta. A different grammar. Well, it needs to be some grammar, right? S, the recursion needs to be on the right. And you cannot change your language. So what you did, you change the language. No, this is not output. This is the input. So what's that? This one? Delta. This is a final. That's an infinite. That's a can recursive, can have a meaning. Basically, you don't need A. You don't need A. Okay, that's fine. Now where is beta 1? I don't have beta 1, I only have beta. Yes. So which one is simple? The general. Yes. All right, let's take a look here, right? So here the form, the general form is S go to S alpha and betas, right? You just need to recognize this delta is your beta. This beta alpha is your alpha. All right, then plug in the equations, right? So the equation is S go to betas, right? Beta now is a delta. delta S prime go to alpha is your beta alpha S prime epsilon. The same. You don't have to use S prime, but you can use other symbols. Here is S prime. We define here. Here's the general forms, right? It's a general form, right? So all the beta come first, right? Followed by S prime, all right? And all the alpha put it here, right? Followed by S prime, if epsilons, right? And we just do the same thing here. This is our betas, right? Beta. So that's our deltas, right? S prime. So this, and it's alpha, right? Alpha is beta alpha, followed by S prime. All right, you can check, right? They generate the same language. You can check, you have to check, but this is what the formula tell you. All right, from left recursion to right recursion, they follow a general form. All right, so what happened? You have one more here, right? You have one more here, not delta. Let's say it's a lambda. All right, what I gotta do? All right, here's just lambda, right? Lambda, that's fine. The general form. Okay, so you just need to understand the general form. This thing's easy. All right, are we good? Clear? All right, next, predictive parsing. So remember what we said, right? Backtracking is not efficient. We like the algorithm to work without backtracking. All right? How can we make the algorithm to work with the backtracking? So we can do that through a look ahead. So here is LLK. So LLK, the first L denote left to right. Second L denote leftmost variations. And the K is the number of K token you want to look ahead. Okay? You remember in Deepwater, when you compile your program using GCC, GCC is a LL1 parser. One look ahead. Okay? So we'll see how can we use this to solve our problem without backtracking. Okay? So here is our grammar. Okay? T, E goes to T or T plus E. And T goes to ID or ID times E or left parenthesis E followed by right parenthesis. All right. So in here, I don't really know which one to choose. They both are T. All right, let's look at one. It's not enough. All right, look at one look ahead is not enough because they are the same. Okay, same for here, ID and ID, they are the same. I don't know which one to choose. Okay, so what's the solution? Rewrite the grammar. All right, rewrite the grammar. So we left factor the grammar. Okay. So this is our original grammar. This is a new grammar. Okay. So now E go to TX. Go to TX. All right. So you have no other choices, right? Only one choice. TX, no confusion. All right. So T, look at T first. T, you can start with ID or left parentheses. Okay, so if I have one look ahead, so I know which route I should take. But because they're different, right? So I know which route I should take. No confusion here. All right. X here is a plus or epsilon. You either have it's a plus sign or it's a nothing. So one look ahead, I know which route I should take. Okay. And same for Y is a star or epsilon. Okay, so that means what with one look ahead, look at one token. So I know either it's going to be a star or it's a nothing. So I know which route I should take. So no confusion. So that means there's no backtracking. Okay, and this is the same grammar. Well, you can look at it. T, X, right? T is ID. So T is here's ID. ID, right? So I have ID here. All right. Y is going to go to epsilon. So this one covers this case. Right? Or T plus E, right? Plus E, all right? Plus E, that followed by X, right? Followed by X. X here is a plus. Plus, right? If the first case is going to epsilon. Okay. So you need to rewrite your grammar in such way, right? With one look ahead, you know which route you should go. Okay, without confusion, right? All right. Okay, is that clear? All right. Next, our simple exercise. Rewrite this grammar, okay, so that it will work with one look ahead. It's very simple exercise. What's your grammar? Where is it? S. So just start from here. E. It's an if. Start with if. It's not E. All right. So simple, right? Look at that, right? I could be E then S, right? I don't have any of them. All right, let's take a look here. So here we have if E then S, right? If E then S, so basically the same here. So we can just eliminate all this, right? Go to have this go to X. So X is either is going to else S or nothing's, right? Right? And with one look ahead, we know which route to go. All right. Are there any questions? Okay, good. All right, so let's take a break and we'll come back. We will talk about your next assignment.